we are given a function h of x, which is a quadratic, right? Because the highest power is x squared, and it's a positive quadratic because the coefficient of x squared is positive. So it'll look something like that. And we're asked to find the x-coordinate of the point on the graph of this function where the gradient is 5. So just looking at a parabola, for a positive gradient, it needs to be to the right of the axis of symmetry. So the point we're looking for might be around here, right? Because if we draw a tangent line, that might have a gradient of 5. Cool. So that's what we're trying to find. Now, alarm bells ringing. We are given the gradient, and we are looking for the x-coordinate. So we need to find the gradient function. So that's our step 1. So the gradient function, h prime of x, to get that, we differentiate h of x. To do that, we take the derivative of each term, and that is in your formula booklet, right? The derivative of a polynomial. So the first term, we take the power, multiply it out the front, so 2 times 0.5 is 1. We then have our variable x to the power of 2 minus 1. Right, we subtract 1 from the power. Right, and in mathematical notation, we don't need to write the coefficient of 1 or the power of 1. So the derivative of 0.5x squared is x. Now the derivative of 3x, the same rule applies, right? It's x to the power of 1, right? Again, we don't need to write it. However, 1 times 3 gives plus 3, and then we subtract 1 off of the power, leaving us with x to the power of 0, which we know anything apart from 0 to the power of 0 is 1, leaving us with plus 3. And finally, the derivative of minus 1, the derivative of a constant, is 0. Again, we can use the rule here because it's x to the power of 0, right? Because x to the power of 0 is 1, so that it's not changing the equation. We take the 0, we multiply it out the front, we're left with 0, which we don't need to write. So the gradient function of h of x is x plus 3. And what this tells us is it relates the gradient h prime of x to any input x. So the question's asking us to find the x value given the gradient. So here we will substitute the gradient of 5 in for h prime of x, and we are solving for x. Right, so the gradient 5 equals x plus 3. Subtracting 3 from both sides, we get x equals 2. So when x equals 2, the gradient of h of x will be 5, right, at that point. And then that's it, we're done. So that would be an achieved question. If you like, I'll just show you how to do it or check on your calculator. This is optional, but it's always good to check. So to check on your calculator, you need to graph the original function. So 0.5x squared plus 3x minus 1. So that will give us a lovely parabola. There we go. Now, you do need to turn on a setting to access this feature. So shift menu, derivative, make sure that is on, so F1. A reminder, the derivative is the gradient. So when you're viewing your graph, a reminder, we hit draw to view our graph. We can hit trace, F1, and trace lets us basically move a cursor around to see for any x value, what is the y value. However, we just turned on the derivative, so it also tells us the gradient at that point. And if we're looking for a particular gradient, we just keep scrolling across until we see what we're looking for. There we go. So when the gradient is 5, our x value is 2. Right, so we know we're right. Pat on the back, and see you next time.